Hi! Today we're going to look at our review for the 4th 6 weeks test. So if you haven't done well on the similarity quiz, or on the test with Pythagorean theorem and special rights, or on the test we just took, if you don't feel confident in those, then hopefully this will help you bring up your grade. Okay? Alright, this first one says a 40-foot flagpole casts a 25-foot shadow. Find the shadow cast by a nearby building that's 200 feet tall. Okay, so when we do this problem, the first thing we're going to want to do is we're going to go ahead and draw our picture. So when I draw my picture, I need a 40-foot flagpole. And it's 40 feet, and it casts a 25-foot shadow. If you think about when you're outside, your shadow doesn't like touch your head and make a hypotenuse. Your shadow comes out of your feet and lies on the ground. So your shadow is going to be down here. It makes a 25-foot shadow. Okay? And so we can see our right triangle is going to be right here, where we have both of the legs. We want to find the shadow cast by a nearby building, and that building is 200 feet tall. And so it's going to do the same thing. It's going to cast a shadow on the ground, and we want to know how big is that shadow. Okay? So when I look at this, I know that they're going to be proportional. So I'm going to set up my proportions, and I'm going to make sure I stay consistent. So if I say that this triangle is going to be in the numerator, this one's always going to be in the denominator. First, I'm going to go ahead and compare the height to the height. So I'm going to do 40 to 200. And then I'm going to compare the shadow lengths. So that's going to be 25 to x. Again, notice the 2 that came from this triangle are both in the denominator. So my 40, or in the numerator, my 40 and my 25 are both in the numerator. And then both of them that came from this triangle, my 200 and my x, are both in the denominator. My heights are both in one triangle. My shadows are both in the other, or one fraction ratio, and the others are in the other ratio. Okay? All right, so now all we have to do is simply cross multiply. So I'll do x times 40, which is going to give me 40x. And then the other side, I'll have 25 times 200, which is 5,000. Okay, so now if I'm trying to get x by itself, I have 40x, which is the same as 40 times x. So the opposite of multiplying here is dividing. Oops. Both sides by 40. And on the left-hand side, both of the 40s cancel out, and I end up with just the x. And on the right-hand side, 5,000 divided by 40 is going to give me exactly 125. And if I look, everything in my problem is given to me as feet. So this is 125 feet. All right, let's look at the next problem. All right, if possible, we want to identify the similarity postulate that makes each set of triangles similar. So our postulates that are possible, we have, if I know that 2 angles in one triangle are congruent to 2 angles in another triangle, the triangles will be similar. I know if all the sides are proportional, the triangles will be similar. And I know if I have 2 sides and the included angle between them, the triangles will be similar. So let's see what we have. My angles are always going to be congruent, and my sides will be proportional. So if I look at my first set of triangles and I look for congruent angles, I can see I have a 61-degree angle here and a 61-degree angle here. And that's all the angles I have marked. I don't have any sides marked, so it looks like all I have is just an angle. But I know from experience that that's not all I have, because we learned the very first 6 weeks about vertical angles, and I told you you'd use those all year long, so we're still using them. I have a second angle. Okay, so since I have two sets of angles, I know that I've got similarity by angle for the first set. Okay, when I look at my second set, I see I still have an angle. 76 matches with 76. So then I need to check the sides. And remember I said when we check the sides, we compare a small side to a small side and a big side to a big side. And again, remember we make sure we do one triangle as always the numerator and the other triangle as always the denominator. And you can pick which one you want to be in the numerator and which one you want to be in the denominator. The small triangle does not have to go in the numerator. It can, but it's not required. Okay, but what is important is that when you compare your sides, you compare the shorter side, which in this case is 9, it's the small side, to the small side of the other triangle, which in this case, between 21 and 40, that's going to be the 21. Okay, so my up arrow comes from the small triangle, so 9 will go on top, and the 21 will go on the bottom. And then we're going to look at our large sides. So my U to V is large, and my F to G is large. And again, the up arrow has to stay in the numerator. So my 18 is going to go in the numerator, and my 42 is going to go in the denominator. Okay, let me make that a little more clear. If that's an 18, I'll put it on this side. 18 in the numerator, 42 in the denominator. These two ratios must be equal for us to say these triangles are similar. So what I'm going to do is I'm going to use my calculator, and I'm going to type in 18 divided by 42, and when I hit enter, I get 3/7. And then I'm going to type 9 divided by 21, and when I hit enter, I also get 3/7. So I do have two sets of sides that are proportional, and then I just want to look and make sure, is the angle included? Is it where the two sides come together? Yes, it is. So that means the angle is in between the two sides. So my second set of triangles are congruent by side, angle, side. Okay? All right, let's look at the next problem. All right, what is the value of x? You will see a problem like this on the test. You have to be careful because it's real tempting to say, oh, 6 to 4 and 12 to x, or 6 to 12 and 4 to x, and say, okay, this is half of 12, so that means 4 is going to be, so x is going to be 8. But let's see if that's really the case, because we need to think of this as two separate triangles. Okay, so what we need to do is we need to look at my first triangle here, where I've got a 4 and a 6, and that's this one. And then we need to look at the big triangle. So my big triangle has an x on the bottom, and the right-hand side of the big triangle is actually 18. Okay? And then we pick a triangle that we want to be in the numerator, and you can do the small one or the big one. I'm going to go with the big one because nothing says I have to put the small one in the numerator. And then I need to compare corresponding sides. So I'm going to compare the 18 to the 6, and then I'm going to compare the x to the 4. And notice again, I stayed consistent with what was in the numerator and what was in the denominator. That's key to solving these problems. Okay, so now I'm going to cross multiply. I'm going to have x times 6, which gives me 6x, equals 18 times 4, which 18 times 4 is 72. So now to solve, I'm just going to divide both sides by 6. Oops. And 72 divided by 6 is 12. So x equals 12, not 8. as we originally guessed. So you need to be really careful, and you really do, in this problem, have to separate your triangles into two separate triangles. Please, please, please remember to do that. Don't just eyeball it. You'll get it wrong every single time. Please, please, please separate your triangles. Okay? All right, let's look at the next one. All right, the next one, it says find the value of x. This was one of our geometric mean problems where we had to set up the ratio. Remember, we said that the altitude of the right triangle was the geometric mean between the two parts that the hypotenuse gets divided into. Okay, so my altitude is right here. It's this one because it's coming from the top of the triangle, and it's coming from the right angle, and it's hitting the opposite side at the 90. Okay, so x is my altitude. So when I set my proportion up, that means x is the geometric mean. And then the two parts that the hypotenuse is getting divided into are 7 and 9. So then all I have to do is cross multiply. X times x is x squared. And 7 times 9 is 63. Then to go ahead and get rid of my square, I need to square root. So x equals the square root of 63, which is 7.937. Okay, so that's an example of one way we use geometric mean in the first unit for this 6 weeks. The second way we use geometric mean is on the next example. So here's the next one, and again, you have to have the altitude of your right triangle drawn in. So your altitude has to leave from the right angle, and it has to hit the hypotenuse at a 90. Okay, otherwise this is not going to work. All right, so when we do that for this one, we said that the leg was the geometric mean between the whole hypotenuse and the adjacent part. Okay, so my leg, in this case, my leg of the right triangle is x, so that's the geometric mean. Between the whole hypotenuse, my whole hypotenuse, I have to travel 3, and then I have to travel 5, so 3 plus 5 is 8. And then the adjacent part, so if I'm looking at this leg right here, the adjacent part, if I look at 3 and I look at 5, the one that touches this piece is the adjacent one, so that's going to be 3. Okay, so now I just need to cross multiply. When I cross multiply, I get x times x equals 8 times 3. And then I can go ahead and unsquare, and to unsquare something, we square root. And the square root of 24 should be just under 5. Let's see, the square root of 24 is 4.899 if I round to 3 places. For those of you rounding to 2 places, in my regular classes, y'all are going to be 4.90 when everything is said and done rounding. Okay? All right, let's look at the next section. The next section moves on to Pythagorean theorem and special right triangles. Remember, if you forget your special right triangles, you can solve them with not Pythagorean theorem, sorry. You can solve them with trigonometry. So if you're like, I've got SOHCAHTOA, that makes sense. When you get to special rights, by all means, use SOHCAHTOA. Okay? My first problem says it's a Pythagorean theorem. Find the length of the hypotenuse of a right triangle whose legs measure 9 and 12. Okay? So I can draw a triangle if I need to. It tells me it's right. And it says find the hypotenuse when the legs are 12 and 9. Okay, now on this one I didn't really need to draw a picture because I know what to do inside my square root if I'm looking for a hypotenuse. So in a hypotenuse, if I'm looking for that, am I going to add or am I going to subtract? For hypotenuse, I'm going to add. So I'm going to take my two numbers, my 9 and my 12. I'm going to do 9 squared plus 12 squared under that square root. So if I do that, 9 squared plus 12 squared gives me exactly 15 for x. Okay, let's look at the next one. This is also a Pythagorean theorem problem. Find the length of the leg of a right triangle with one leg of 16 and a hypotenuse of 34. So again, I've got a right triangle where one leg is 16 and the hypotenuse is 34, and I want to find that other leg. Okay, so when I look at this, this time I'm trying to find a leg, so when I do my square root this time, instead of adding, I'm going to subtract. So my two numbers are going to be 34 and 16. The bigger number will always go in first. So when I put that in my calculator, the square root of 34 squared plus 16 squared gives me 37.577 when we round to 3 places. Okay? All right, let's look at the next one. All right, so for my next problem, it's real tempting to look at this problem and go, oh, special rights 30, 60, 90. If I were to re-sketch it, I've got 16 for a hypotenuse, so this is 8, so this is 8 square roots of 3. But if I look and I have an isosceles triangle, nothing here tells me in this, oh, and it says x, sorry, I forgot to tell you. This is a typo, it should be h. We're finding the height of this isosceles triangle, okay? We don't have anything in this that tells me that I've got 60-degree angles. In fact, I know I don't because this triangle is clearly not equilateral. I've got two sides that are 16 and I've got a side that's 20, so it's not equilateral, which means I don't have a 60-degree angle in here. So I can't use that. That's not going to be my correct answers. That's not going to work for me. Okay? When I see an isosceles triangle, I need to remember that the height or the altitude divides the base into congruent pieces. So if the whole thing is 20, then each side is 10. Okay? So then from there, I can look at just one side as a right triangle. And then this becomes a Pythagorean theorem problem, where I'm looking for a hypotenuse or a leg. In this case, I'm not across, this side that I'm looking for is not across from the right angle, so that means I'm looking for a leg, so I want to subtract. When I look at my numbers, 10 and 16, I know the bigger number will go in first, so that's going to be 16 squared and 10 squared. So the square root of 16 squared minus 10 squared gives me 12.49, which is not 8 square root of 3, which I thought it was earlier. If I look at 8 square root of 3, that's 13.856. So they're a little bit different. Enough different that you would get it wrong on a multiple choice. Okay? All right, let's look at the next one. Can the following set of side lengths form a right triangle? Okay, so in this one, this is the one where we tested, does a squared plus b squared, does it equal c squared? Okay, so what we're going to do is we're going to say, all right, when I look at this problem, I want to know if I take my two smaller numbers and then reserve my bigger number for c. So I'm going to take the first two smaller numbers and I'm going to do the square root of 4 squared plus the square root of 9 squared. And I want to know, does that equal the square root of 25 squared? That's a 5. Doesn't really look like it, but trust me, that's a 5 right there. There we go. All right, so you might remember that when you square a square root, it cancels out. So in this case, it's actually easier if they're all have square roots. It's easier to do it without the calculator, believe it or not, if they have square roots, than it is to do it with the calculator. Because the square root of 4 squared, when I look at this piece right here, the square root of 4 squared, the square and the square root cancel. So what I end up with, when the square and the square root cancels, I just end up with 4 plus, and then on the other side, when the square and the square root cancel, I end up with just 9. And I want to know, does that equal, over here, the square and the square root cancel, I have just 25. Well, 4 plus 9 is 13. So no, they're not equal. No, I can't make a right triangle. Okay, so now let's look at the next one. The next one, my biggest number is the 25. So that's going to be reserved for my C, and I'm going to check these two. 15 squared plus 20 squared, 20 squared, and I want to know, does that equal 25 squared? So this time I'm going to go ahead and go to the calculator. 15 squared, which is 225, plus 220 squared, which is 400, gives me 625. So then when I check 25 squared, I also get 625. So these are equal, which means yes, they do make a right triangle. Okay? All right, so then when we check this last one, I'm going to do the same thing that I've been doing. I'm going to see which one is my biggest. That's going to be my C. So then the square root of, the square root of 4 squared plus the square root of 9 squared, does that equal the square root of 13 squared? Okay, and then remember, just like last time, my square roots and my squares cancel, so that first one is just 4. And then my square root and my square roots cancel, so that next one is just 9. And then my square root of 13, the squares and the square cancel, so that becomes just 13. In this case, 4 plus 9 is 13. So 13 does equal 13, so this is also a yes. Okay? So remember, that's the Pythagorean theorem converse. Let's look and see how we can apply it a little bit more specific. When I look at these next problems, it says to classify as acute, right, or obtuse. So this is the one where we do what we just did, only we end up looking at the final answer and determining, is my C too big, too small, or just right to be a hypotenuse? Okay? So again, when I look at my problems, I'm going to start with identifying what would be my value for C. So I'm going to do the other two, 9 squared plus 39 squared, and I'm going to compare that to 41 squared. So 9 squared plus 39 squared gives me 1,602, and 41 squared gives me 1,681. So when I look at the right-hand side, the one that is supposed to be the C, so this, remember, is supposed to be my C. When I look at the side that's supposed to be C, it's bigger than the other side, so that means it's too big, which means this triangle would be obtuse. Okay? Let's look at the next one. I'm going to do the same exact thing. I'm going to say, all right, 17 is my biggest number. So I'm going to start with the first two, 8 squared plus 15 squared. And I'm going to say, how does that compare to 17 squared? 8 squared plus 15 squared is 289. And 17 squared is also 289. So when I look at the one that we said was the hypotenuse, we see it is just right. So that means it is a right triangle. All right, let's look at the last one. When I look at the last one, again, the 19 is going to be my side that is the biggest. So I'm going to start with 12 and 16. And I'm going to compare that to the 19 squared. 12 squared plus 16 squared is 400. 19 squared is 361. So when I look at the one that I thought was supposed to be a hypotenuse, I can see it's supposed to be 400, but it's too small, which means this triangle would be acute. Okay. All right, let's look at the next section. The next section says find the perimeter of a square that has a diagonal of 13.75 square roots of 2. So I want to think about a square. And it says the diagonal is 13.75 square roots of 2. And remember, this whole unit is all about right triangles, so we want to think about where we see a right triangle. So I see a right triangle right here. And we talked about when we divide the diagonal, we put the diagonal in a square, that's how we end up getting 45, 45, 90 triangles. Okay, so if I have a 45, 45, 90 triangle, and I know my hypotenuse, I need to find out what my two legs are. I know they're congruent because it's a square, right? And so we have two options. We could use our special rights, or we could use trig, even though this question is actually considered a special right question. If you forget the pattern, you're more than welcome to go trig. The pattern says on a 45, 45, 90 triangle, you're going to have two congruent legs, here and here. And if I call them x, then my hypotenuse would be x square root of 2. So if I'm trying to figure out what this value for x is, and I know that this is x square root of 2, I can see, oh, if I take the square root of 2 off, I know that x is going to be just 13.75. Be careful not to put that as your answer. Because remember, this question is asking for the perimeter of the square. So that means I need to know all 4 sides. So I have to do the 13.75 plus 13.75 plus 13.75 plus 13.75, or I could just do 13.75 times 4, which gives me 55 for my perimeter. Okay? Now, for those of you who don't remember the pattern, if you don't remember the pattern, don't panic, right? Because you can say, all right, I know this angle is 45. And I know what this is. I can change that into a decimal. 13.75 times the square root of 2 in my calculator, make it a decimal. and I can deal with and say, all right, if I need to know what this leg is, that's the opposite. This is the hypotenuse. So I know opposite and hypotenuse, so I'm going to do sine. And you can set up your trig ratio, and you will still get 55. I promise, Scout's honor. Okay, so if you forget your pattern, use trig. I won't know the difference when I grade your test. I won't know which method you used. Okay? All right, let's look at the next one. The next one, find the length of each missing side of the given triangle. Again, this is a 30, 60, 90 triangle, but nothing says you couldn't say, all right, I'm standing here. This is adjacent. Oh, I'm not even smiling. That's a sad little smile face. This one's opposite, and this one's hypotenuse. And you could set up a trig ratio to find the opposite, and then you could set up a trig ratio and find the hypotenuse. You just have to do 2 sets of trig, which is not a problem, easy to do, okay? But since this is supposed to be the special right triangle section of our review, I'm going to do it with special right triangles with my 30, 60, 90, okay? So my 30, 60, 90 rule states I have a hypotenuse across from the 90. I have a short leg across from the 30. And I have a long leg across from the 60. And the short leg was the key. That's the one we need to know, because then the hypotenuse is just 2 times that short leg. And the long leg, a lot of you like to say, take the short leg and add a square root of 3, but technically we shouldn't say that. I saw a lot of that in your critical writing that we did last week. And I probably said it too, just because it makes sense to say that, because you're just kind of sticking it on the end. But really, remember, we want to think you're not adding the square root of 3. You are multiplying the short leg times the square root of 3. Okay? All right, so when we look, if my short leg is 45, then my hypotenuse is going to be 2 times that x of 45. So this side's just going to be 90. And then my long leg is going to be that 45 multiplied by the square root of 3. Okay? Now, if you were to do trig, okay, you're not going to get, your calculator's not going to give you 45 square roots of 3 as an answer, because it's going to, your calculator's going to give you the decimal. So what you're going to have to do is you're going to have to look at your answer choices. And you'll probably have, like, I don't know, 45 square roots of, if I can get my pen to work, square roots of 2, 45 square roots of 6, I don't know, 90 square roots of 3, and 45 square roots of 3. So we know it's D, but what you would have to do is type these in your calculator and hit enter until you said, okay, this last one gave me 77.9423, which is what my calculator gave me when I did trig. Okay, so just keep that in mind, that your answers on the test are going to be written in special right format. If you use trig, you just have to convert the answer choices to decimals. Okay? All right, let's look at the next one. All right, the next one says, find the value of x in each triangle below. So here's my first triangle. Now if I look, I have a 42-degree angle. So now I'm on my trig. I can't do special rights because this is a 45, this is not a 45, 90, and it's not a 30, 60, 90. So I do have to use trig. Okay? Remember, the first thing we do is we figure out what angle we've been given that's acute. So that's going to be this 42. And then I look across my triangle, or I look at my across the 90 to find my hypotenuse. And then my adjacent, remember, is the other side that touches that angle. So not the hypotenuse, but the x. And then the opposite over here. Okay? And then I said the next thing that we do is we circle the one that we know and the one we want to find. And we compare that to SOH, CA, TOA. So I circled opposite and I circled adjacent, so I can see I'm going to use tangent. So when I set up my my trig equation, I say tangent of the angle 42 degrees equals opposites on top, adjacents on the bottom. So opposite is 4.5 and adjacent is x. Okay? The next thing we did is we set it up into a proportion because we're going to cross multiply. Remember, if you're looking for a side, you cross multiply. And if you're looking for an angle, that's when you use the inverse function. Okay, so in this case I'm going to cross multiply, so I end up with x times the tangent of 42 equals 1 times 4.5. Now here's where the problem can differ a little bit because we have to decide, do I go straight to the calculator or do I need to divide? To do that, we look at the symbol that's right next to x. If it's a multiplication, we need to divide. If it's an equals, we can go straight to our calculator. So since it's a multiplication right here and not an equals, we are going to have to divide. So I'm going to divide both sides by the tangent of 42. So now on the left-hand side, my tangents canceled. I just have x. And on the right-hand side, before I ever put trig in the calculator, I need to check it and make sure that it is in degrees, which my calculator is. So I'm going to do 4.5 divided by, I'm going to hit the trig button right next to the 7 on the calculator. Arrow over to tangent and type in 42. And I get 4.998 when I round appropriately, if I'm rounding to 3 places. Okay. All right, let's look at the next one. Find the value of x in this triangle. So when I look, the first thing I'm going to do is figure out which acute angle am I standing at. So here's me. Okay. My hypotenuse across from the right angle is 5. If I look at the two sides that touch this angle, one's already been labeled as the hypotenuse. The other is the adjacent, which leaves the opposite. Okay? Alright, so now I'm going to circle the one I already know. That's my hypotenuse. And the one that I'm trying to know, that's my opposite. And then I look at SOHCAHTOA. Okay, so I have circled opposite, and I have circled hypotenuse. So the trig function I want to use is sine. The angle I'm standing at is 53 degrees. Sine is opposite over hypotenuse. My opposite is x. My hypotenuse is 5. Again, remember, if I'm looking for a side, I'm going to cross multiply. And if I'm looking for an angle, I'm going to inverse. So in this case, I'm trying to find x, which is an opposite side. So I'm going to cross multiply. X times 1 is x equals 5 times the sine of 53. So remember, I said what we do next is we want to look at our symbol right after the x. In this case, my symbol is equals. If you have x equals, that means you're ready to type in the calculator. So in the calculator, I'm going to type 5 times. I'm going to hit the trig button and choose sine of 53 degrees, which gives me an x value, when I round to 3 places, to 3993. Oh, I forgot my decimal. My decimal's right here, 3.993. All right, let's look at the next one. All right, so same thing. I'm going to look at the angle I'm standing at because, again, we're not a 45, 45, 90. We're not a 30, 60, 90. So we can't just use a pattern. Again, if we were 30, 60, 90, or 45, 45, 90, we could still use trig. That would still get us the exact same answer. I'm standing here at angle A. My hypotenuse across from the right angle is the 14. And then remember, hypotenuse touches one side of the angle, and the adjacent side touches the other, which leaves the opposite. Okay? All right, I know the hypotenuse is 14. I'm trying to find the adjacent side. So, toa. I have circled the hypotenuse, and I have circled adjacent. So the trig function that has two check marks is my cosine. Cosine, I'm standing at 24 degrees, equals A over H. My A is X, and my H is 14. Again, X is a side, and so for a side, I'm going to cross multiply. For my angle, I'm going to inverse. So in this case, I want to cross multiply. When I do that, I get X times 1, and then 14 times the cosine of 24. And again, we look at the symbol right after the X. The symbol right after the X is an equals. That means we're ready to go to the calculator. So 14 times the cosine of 24 gives me 12.789, but after the 9 is a 6, that bumps the 9, so 12.790. If I round correctly to 3 places. Okay? All right, let's look at the problem. Find the measure of the indicated angles below. So the indicated angle is going to be the one with the symbol in it. The symbol's a theta. It's a Greek letter. Okay? So I'm standing right here at angle A. I'm going to do the same thing I did before. I'm going to label across from the 90 as my hypotenuse. The hypotenuse touches the angle along with the adjacent side, leaving the side all the way across the triangle as the opposite side. Then when I look, I know my hypotenuse. I also know my adjacent. There's not a side I'm trying to find. I don't have an X on a side. I'm going to look at SOHCAHTOA. I circled adjacent, and I circled the hypotenuse. So the one with two checks on it is the cosine. The cosine of the angle I'm standing at is that weird like circle with the line through it, the theta, equals cosine is adjacent over hypotenuse. So adjacent is 6, hypotenuse is 9. So remember, when we're looking for a side, we cross multiply. And when we're looking for an angle, we inverse. I can see right here it says I'm looking for the indicated angle. So I know this time I want to inverse. So we rewrite our equation, the cosine, and then we say it's the inverse cosine. So we put a little -1, meaning inverse. And then instead of putting our angle, we switch it with the ratio. And that is going to give me the value for theta. So in the calculator, when I hit the trig function, or the trig button next to the 7, the second row of trig functions are my inverses. So I'm going to choose the cosine with the little -1 of 6 divided by 9, and that gives me 48.19 degrees. So my angle equals 48.19 degrees. Okay? All right, let's look at the next one. Same thing. I'm going to figure out what angle I'm trying to find. That's the angle I'm standing at. And then I'm going to label my sides. I've got a hypotenuse across from the 90. My adjacent is the other side that touches the angle. And then all the way across opposite is my opposite side. Then I look and I say, okay, I know the adjacent is 10. I know the opposite is 11.9. And I'm not trying to find another side. I don't have an X. So I just have to look at those two. When I look at SOHCAHTOA, I've circled opposite and I've circled adjacent. So the trig function I want to use is tangent. Tangent of the angle equals opposite over adjacent. So opposite is 11.9. Adjacent is 10. And then we need to think about, remember, sides cross multiply, inverse, angle, inverse. And again on these, this time I'm looking for angles. So I know I'm going to inverse. I'm going to do the tangent with the little -1, and then I'm going to put my fraction, and that's going to give me the answer for the angle. So trig, choose the tangent on the second row, and 11.9 divided by 10 gives me 49.959. And I know we rounded these usually on our homeworks and our assignments and in the notes to the nearest whole degree, but since it didn't say that in the directions, I'm going to my old standard by of 3 places. It will be multiple choice on your test for tomorrow. So it might be rounded to the whole degree. If so, then we would just say 50 degrees. Okay? All right, the next one, find the measure of the indicated angles below. So again, I'm standing right here. Here's my hypotenuse. My adjacent is the other side that also touches this angle. And then opposite is the one all the way across on the opposite side of the triangle. I know the hypotenuse. I know the adjacent. I don't have an X on one of my sides. When I look at SOHCAHTOA, I've circled the hypotenuse and I've circled the adjacent. So the trig function I want to use, cosine, because that has 2 check marks next to it. Cosine of the angle is the theta equals adjacent over hypotenuse. So my adjacent is 4 and my hypotenuse is 5. Then I think, what am I trying to do to solve? Am I looking for a side or am I looking for an angle? If I'm looking for a side, I want to cross multiply. If I'm looking for an angle, I want to inverse. In this case, I'm looking for an angle, so I'm going to inverse. Cosine with the little -1 of the ratio, 4/5, is going to give me, the theta, the angle. So my angle equals, trig button, cosine from the second row with the little -1, 4/5, 36.87 when we round to 3 places. Because after that would be a 0. All right, let's look at the next one. Find the length of x as a decimal rounded to 3 places. So this one we could use trig, okay? We could say, all right, so the first thing I need to do is I can look at this triangle here. And I can say, all right, I'm standing here. And my hypotenuse, this is my right angle. My hypotenuse is here. And I need to find this side, my opposite side. So I could say, all right, sine of 60 equals opposite over hypotenuse. And I could find, well, I shouldn't use an x there, right? Because x is what I'm trying to find ultimately. So maybe instead I could call this y. So that way I don't get confused with that x. And then I could find that one. And once I knew what that was, then I could say, all right, if I'm looking at this angle, I could say this one's a hypotenuse for the green triangle. What's kind of nice is this is still an opposite for the green triangle. So then I would be doing, still opposite in hypotenuse, I would be doing the sine of, this time 45, is going to equal opposite over hypotenuse, so it would be whatever I found for y over x, and I would cross multiply to find x once I plugged in y, okay? But rather than doing all of that trig, rather than doing all the trig, we can treat this because I see I've got a 60-degree angle in one right triangle. That triangle is a 30, 60, 90. And I have a 45-degree in the other triangle. I can just do this as special rights. So again, this is going to be counted towards your last test because it wants it in 3 decimals, so we can do it with trig so that we can get our decimals. But you'll see, if you know your special rights, it will go a little bit quicker than having to set up all the ratios. Because when I look at this triangle here, my 45, 45, 90, or sorry, my 30, 60, 90, where I've got my short leg, my hypotenuse, and my long leg. If my hypotenuse is 42, then to get to my short leg, all I have to do, the hypotenuse is 2 times the short leg. So on doing the 2 times the short leg, I divide it by 2. My short leg's 21. And then my long leg is the short leg times the square root of 3. So my long leg is 21 square roots of 3. Okay? So then if I look at this triangle, where I've got a 45, 45, 90, and this leg here is 21 square roots of 3 because we just found it. That means this one's also 21 square roots of 3. And then the hypotenuse is the leg times the square root of 2. So that's going to be 21 square roots of 6. Now it does say to find it rounded to 3 places, so I'm just going to type that in my calculator. I'm going to do 21 square roots of 6, and I'm going to hit enter and see that I get 51.439. So we didn't have to do our trig. Okay, so let's try one more of those so you can see how you can do it with trig, but if you know your patterns, it will go a little bit. Okay, so when I look at this next one, the only side length I see is here, the 42. Okay, and it's on my 45, 45, 90. Now usually the hypotenuse on your 45, 45, 90 has a square root of 2 on it. So if it doesn't, that means we had to divide the square root of 2 out, which divides the 42 by 2, and then moves the square root of 2 to being next to it. Okay, so then when I look at my 30, 60, 90 triangle, I'm trying to find my long leg. My short leg is 21 square roots of 2. My long leg says take that short leg and just multiply it by the square root of 3. So I end up with 21 square roots of 6, which we actually just found they happen to come out to the same thing. I end up with 51.439 when it asks me to round it to 3 places. Okay? All right, let's look at the next one. Find the length of the diagonal of a square whose perimeter measures 84 centimeters as a decimal rounded to 3 places. All right, so I have a square, which means when I put my diagonal in, I know I end up with two 45, 45, 90s. Okay? If the perimeter is 84, then to find each side, I can just take that and divide by 4, leaving me with 21. Which means my diagonal is the leg with a square root of 2 on it. Again, you could use trig, because you could say, oh, if this is 45, then opposite and adjacent, tangent of 45. Or sorry, we wouldn't want to do tangent. We would do either sine or cosine, because we do opposite over the hypotenuse, because we'd be trying to find the hypotenuse. Okay? Now, it does say rounded to 3 places, so 21 square roots of 2. If I put that in the calculator, 21 square roots of 2 gives me 29.699. Okay? All right. So your test is going to be tomorrow, and it will be on the Chromebook, but to save you a little bit of time, instead of having to draw each picture on your own on your scratch paper, I'm going to give you all the questions on your scratch paper, and on your scratch paper they'll be divided by all the things from the first quiz will be together, all the things from the first test will be together, and all the questions from the last test from last Friday will be together. Okay, but the computer randomizes the test questions, so they won't be in the same order on the computer as they probably are in your test. So you might have to kind of look around and see, oh, okay, where is this? Oh, there it is. We're good. Okay, but you won't have to draw all your own pictures. Okay, all right. If you have any questions, make sure you stay today for tutoring. Or come in tomorrow morning, because I believe it's not a late start. So Wednesday morning will work for tutoring this week. All right, your test is tomorrow on Wednesday.